In the outback of Australia, a group of self-proclaimed geeks are gearing up for a challenge.
Flame power can be disabled when you're ready. Panda board is off.
And found a couple other geeks who are just as crazy as I was.
That was the show.
A challenge that has been run for many years and never been won.
We all hope that this year is the year that the $50,000 is going to go.
Their mission is clear. Find Outback Joe. The catch is they have to do it using one of these.
Well, in the military, they're referred to as drones by the press. Generally speaking, within industry, they've been called UAVs or unmanned aircraft vehicles. As far as the civilian side of the world is concerned, we're now starting to move to new acronyms such as RPAS, which is Remotely Piloted Aircraft Systems. The term system has been used because we are dealing with a system. It involves technology that flies in the air, which is the aircraft or the platform with a brain on board.
One of the real myths is that they're just out there operating completely uncontrolled. You know, that's not true, in fact, because you still have a pilot on the ground rather than on the aircraft. So that pilot is still talking to air traffic control, still getting clearance to take off and land, talking to other aircraft and making sure everything's safe.
Now, the way in which they can control it are in three methods. Typically manual, which is effectively like an RC aircraft would be controlled. What we call stabilised mode, where the aircraft itself is actually maintaining a certain type of attitude, which the pilot can manually control. However, the aircraft's doing a lot of the work to keep it safe and sure. And then there's another term which is called semi-autonomous, which is where the actual computer on board the aircraft is doing all the work.
And now we see UAVs used for civilian purposes, and that's our real interest in the search and rescue UAV challenge, is how we use these sorts of vehicles to go and find people and do good things in the civilian world.
The freeway was closed for hours as crews worked frantically to retrieve the truck. The fire brigade using a drone to assess the extent of the damage.
If we apply this technology, in a constructive way, then there won't be any looking back. It will actually help and take over a lot of the jobs that most people would never want to do, and it will keep Australia, at the forefront.
Over the coming days, 5 teams in Kingaroy, central Queensland, will be in for a bumpy ride, one with plenty of ups and downs. With 18 months of hard work and $50,000 on the line, the teams are taking this challenge very seriously.
You're only as good as your last landing.
Fantastically happy. It couldn't have been better, really.
And today was a particularly bad one.
This is a lot harder than most people think. Teams have to go and find Outback Joe. And Outback Joe is a lost bushwalker, and he's a mannequin. He's been lost about 10 kilometres from the airport. The teams don't know exactly where. The team's then got an hour. They have to fly their aircraft autonomously, so they can't radio control it. It's actually got to fly by itself. They've got to find Outback Joe, and if they've found Outback Joe correctly, they then tell us the coordinates, and if that's actually very close, we allow them to then drop a water bottle. They've got to get that water bottle within 100 metres of Outback Joe, and then safely return to the airport.
Out of the 70 teams from all around the world who entered this year, only 5 have made it to Kingaroy.
We've done a lot of airtime. We've had was 1,100 minutes, which is about 8.5 hours of airtime in autonomous flights with that, plus a lot of radio control. I've done countless landings.
So the guys at the moment are just getting our computers on board, our autopilots, our termination systems, and we're making sure they're all working, functioning correctly. All the systems are working, images are being captured, the autopilot's thinking the way it should be thinking.
And the wind here for this light plane, well, in my opinion, quite extreme, but everybody has their opinion, of course. But they're used to it, but we don't have thermals like this in the Netherlands.
We're from Canada, from Toronto, Ontario.
We know about this competition actually a while ago, but we always this Australian competition. We've heard about it, but then we thought that maybe we could do this.
Right from the beginning, we decided we'd go for maximum automation. So we decided we'd do, even our first deliverable, we said, auto takeoff, auto landing, auto search, the whole bit. Just because, that's maximum fun. Because we're geeks and, more technology, more automation is fun.
The sort of issues we were trying to tackle were raising public awareness of unmanned aircraft, so the public really gets to understand the technology a bit and what the applications are. There was always questions about whether people could get insurance to use unmanned aircraft, so we thought having a challenge would force that issue. And of course the last point is actually getting new innovative sort of ideas out there about how to use unmanned aircraft. So we hope that getting these teams and university teams and hobby teams, they'll come up with some great new ideas that industry hadn't thought of yet.
So if we think back to 2011 when the floods were occurring in Brisbane and throughout Queensland, there were some great opportunities to use unmanned aircraft then, but the risk and regulations and the technology wasn't quite mature enough to be able to throw in at short notice. And so we took that as a lesson and thought we need to be able to make sure that next time around the emergency services people have the option to use unmanned aircraft.
Currently, all aircraft are used in floods to actually try and figure out what's going on and also, of course, rescue people. So in the floods we saw last time, there were people stranded on car roofs, on the roof of their house. Now, we need helicopters to actually go and pick these people up, and really there just aren't enough helicopters to pick everyone up fast enough. So we'd like to free up some of the helicopters that are currently being used to see what's going on and do surveillance, and actually free them up, get the UAVs to do the surveillance and maybe fly higher than the helicopters and figure out who needs saving and what's going on, and then allow the helicopters to do what they're really good at and actually go and pick people off the roofs.
That 20 to 25, maybe 20 to 30 kilogram mark is around where we think the economic point is for those kind of operations. The aircraft's capability is more than adequate. You've got payload ability and you've got the endurance that you need to be able to do it.
Back out at the competition, things are starting to get very real for the teams.
So, of course, at the heart of all these systems is an autopilot, and the teams use various different flavours of autopilots. Then the aircraft themselves, some teams buy kits, some teams buy aircraft that are already pretty much made, but they don't have the autopilot, and some teams just build from scratch. They come up with their own designs and build it from nothing. And then, of course, there's the communication system, and that's where a lot of teams actually struggle. The range is quite long, and they actually need to, be constantly communicating with the aircraft back from here at the airport all the way down the search range, and that's a difficult thing for a lot of these teams to do.
Joe is lost in a search area that covers around 700 hectares.
When you actually drive out to the range, you can't quite believe how far how far away the search area is. It always surprises me when I drive out there. I say, surely we must have gone past it, and we're like, no, we're not even there yet. So it's a very long way, and I think that surprises many of the teams.
Because the aircraft are flying autonomously, care is taken to prevent any incidents where an aircraft gets a mind of its own and heads outside the defined boundaries. Working closely with the regulator CASA, Civil Aviation Safety Authority, a solution was found, called geofencing.
So the concept of the geofence is that there's a boundary marked by coordinates, and the aircraft must be able to show through scrutineering that if it crosses that boundary, that it enters flight termination mode.
There's a lot of work in dealing with the regulations to make sure we do this in a safe way and in a way that the regulator, CASA, is comfortable with.
Before the teams can get airborne, they have to be statically scrutineered by the judges.
All right, so of the, I think we had 5 teams that were going to be statically scrutineered. How many passed?
So far, 4 teams passed.
Yeah.
So 1 team still has to do 1 test, and it seems they have a problem with the position accuracy of their GPS, what could be related to the ASPAS augmentation system that is not available in Australia. They come from the Netherlands, so I told them, disable that system and we try again.
And Roger, how's the judging been going?
Good. I'm looking at how these teams face the challenge of the search and rescue aspects.
We're doing automatic Joe recognition. It finds the position, finds the geo-reference, and is able to then plan the bottle drop, the whole bit, using the onboard computer system.
Yeah, here's an example here. So it comes out the tube, and then with a rubber band on top, they'll deploy and start spinning up, which reduces the terminal velocity and comes down, and the bottle doesn't break, it's inside it.
We built our own image recognition system based on a machine vision camera we have on the bottom of the plane, roll stabilised machine vision camera, controlled or stabilised from the autopilot, but the recognition is actually happening all on board regardless.
So are any of them automatically detecting Joe? Have you seen any automatic detections?
I believe there are plans for them to do that. Some may attempt that, but I don't know how successful that'll be.
So that allows us, in theory, to press a button, the whole thing goes, find Joe, drop the bottle, come back, we have a coffee. That's the design, but of course we'll actually be sitting there like this.
In the beginning, none of us knew anything about UAVs. I mean, the past 18 months we've had to teach ourselves everything about this from scratch. We've learned so much in this process. We are continually learning everything from radio systems to autopilots to cameras, so aerodynamics of aircraft and flight. There's so much stuff to learn.
With Open UAS cleared for flight, it's not long now until the teams take to the skies. Although this is a relatively new development within the aviation industry, UAVs are already proving to have some pretty handy uses in the civilian world.
Yeah, they can be used to carry multispectral cameras, and the information a multispectral camera can collect over a crop will enable a farmer to achieve 2 things. Ultimately, reduce the number of inputs, such as fertiliser, pesticides and water, and at the other end, be able to produce a greater yield from the same piece of ground.
Look, a farmer knows his paddock and his crop, really well. They've been farming it for year on year. So when they walk into a paddock and look at a crop, they know whether it's good or whether it's bad or it needs something done to it. What imagery does is allow them to transfer that knowledge at that point to the whole paddock.
Then what we do is we fly over with a multispectral camera, and this slide here is, or this image here is representing all of those images that have been taken of the paddock. The end result that the farmer gets is a map that basically says not enough fertiliser, too much water, etc.
The thing about the UAV is that it will be able to do things in a much more timely fashion now. In the past, traditionally, we've had to use satellites and manned aircraft to collect that information, but with a UAV, which you can store on site, you could nearly fly the crop every day or as required.
Back at the competition, 5 teams are battling it out. They need to demonstrate to the judges that their plane can fly autonomously, safely. For a task that most teams feel pretty confident about, disaster is looming.
At any time we feel uncomfortable, we'll just give you a simple command to land the plane. So I thought I was doing proficiency tests, and I obviously flew too far over there and went outside the geofence boundary, and that is what's supposed to happen, and it worked perfectly, and that's the result. So I think that's out for us. On the way over, I don't think reality hit. I thought I might wake up and be back at the hall where we're staying. The Baptist Hall, they put us up. Thought, I'm going to wake up and I'll be at the hall and then we'll come out and do it all again. But no, it wasn't to be. So my son was beside me, said, I hate to tell you this, but no, this is real. You can tell a good landing from a bad is how many times you have to bend over to pick up the pieces. And today was a particularly bad one.
If anybody new comes to the challenge, they soon learn about the Kingaroy Triangle. And this started really on the first challenge back in 2007, where the teams would report they had really great systems. They all worked perfectly until they came to Kingaroy, and then mysterious things started to happen, a bit like the Bermuda Triangle.
My granddaughter lives across the road and she always talks about our competition airplane, and unfortunately I won't be able to show it to her when we get back, but it's just a shame that it ends this way.
There's a rule, it's called loss of RC. You have to go into flight termination, and you cannot recover. So if you have a split second of RC loss, then it has to terminate, and that's what happened. You cannot control it anymore, you cannot do anything. Good. That was the show.
Our interpretation of what we think is a safety requirement, which obviously has very harsh penalties, and what some of the teams see, there are often differences and we have to work through those.
It is what it is. We have to adhere to the rules to participate, and this is the consequence.
We also were not planning to fly manual in the competition. We were only team that submitted a year and a half ago already to fly autonomously, and then you would not have a loss of RC link, obviously.
It would perfectly fly like we do normal.
They actually explicitly said don't do an auto takeoff.
Yeah.
So
it's okay.
It is what it is.
It's a difficult challenge.
Of the job. So good luck to those who are still in the running.
We try as a technical committee and the judges to be quite fair. What we want is a spirited competition, but a fair competition for each team.
It looks like this team here is having some sort of problems with their radio communication. So they've come here, unloaded everything from the car, put it all together, and it isn't working. So maybe there's a connection error, maybe, I don't know, a wire's loose, who knows what's wrong, but they're trying to find out right now.
Yes. What I wanted to find out is that we know this system works. We've had it working many weeks, and for some reason, even though we had it running recently, even in the last sort of 24 hours, it's not appearing to work now.
Oh, there's always something. So these are quite complicated machines, and there's usually little teething problems when they arrive.
It looks like luck is on their side. With the weather turning bad, the judges decide to postpone the scrutineering flights until tomorrow morning.
We guys were up till 1 o'clock last night, so just running simulation after simulation, tidying up the plane, making sure everything's laid out well.
I'm very, very happy. That's just all our hard work last night was worth it. It's just incredible.
Elevator up, elevator down, right or left, right or right, okay.
And look who makes a surprise entrance with a fully repaired plane.
Well, but this will be the first flight of a repaired airplane. It's quite challenging.
Are you happy with how that went?
Fantastically happy. It couldn't have been better, really. I mean, it's repaired in a night airplane, and I had no clue about the settings because I've never flown it in this state. Because if you crash, it's basically, you need to guess a little bit the values.
At last, all the scrutineering flights are complete. Only 4 teams out of the 5 have made it to the final stage of the competition. It's a disappointing blow for the Wild Hogs.
Yeah, there's some real highs that we've had, some interesting times. Being built together as a team, a lot of personal stuff invested in it. Yeah, so, yeah. What happens after this, we'll do a restock and see what happens.
Our company's been working with Surf Lifesaving Australia on developing a robotics project where a UAV would be integrated as a tool to assist in surf rescue. Every year, 70 people drown on the beaches around Australia, and what we're trying to do is identify with Surf Lifesaving ways of using this technology to assist in reducing that number. With things such as deployable flotation devices, we can provide effectively first aid using the UAV as the source of that aid delivery. The actual rescue itself would still have to be affected by the surf life-saving assets they have, whether it's a boat, a swimmer, or a Westpac helicopter. But what the UAV can do is basically pinpoint where that incident is occurring so that people can go straight to that area of response. We also believe that these devices can be used to identify predators in the water, such as sharks, and if that is the case, we believe that certain technologies can be used to ensure that the sharks and the humans are separated. So hopefully we can produce a patrol where not only are you seeing who's out there in the water and that they're not in distress, but if there is a threat, that threat can be mitigated by technology.
Where you used to take a manned aircraft and the idea was to prove there was no environmental damage, you had to look for mammals and whales in the area before you did your mining. So to do that with a manned aircraft, you need to fly very low level over the water with effectively people hanging out the windows with a camera, taking photos and counting the whales. So in order to make it safer, they asked us to do a trial for them and use our UAV to fly low level over the water with a very similar sort of camera, and we can do that quite safely. And even if we happen to lose the UAV, then there's no lives lost. So it's just the cost of a replacement UAV. That doesn't happen very often, but it's nice to have that safety factor, and that's where we're seeing a lot of the interest in doing that sort of work.
So here we have Outback Joe set up ready to be found and rescued. He just laid out on the ground here. We've got an infrared camera just in case people want to be able to see some thermal activity. I've marked the GPS location and now he's ready to be found. Competition begins.
It's extremely hard. Nobody's ever won the Search and Rescue Challenge. Many have tried and many teams have come very close.
We don't want to keep the money, we want to see someone achieve the challenge, and the challenge for us, if that is met, is that we have to come up with a new challenge.
Okay, so this team is just over halfway through their allocated 1 hour of flight time. They've been collecting data. They can't analyse it online. The aircraft is returning now to base. They'll download the video, see if they can find Joe, and then make decisions. If they've found Joe, they'll give us the coordinates. We'll see whether or not that actually is where Joe is, and if that's okay, then they'll put their water bottle on, launch out to deliver to Joe.
After a promising start, the team is having trouble retrieving data from the onboard camera.
5 minutes remaining.
I don't think it was working.
Okay, so... Oh well. So you're happy to call it from there?
Yeah.
Okay.
Yeah.
So just to put it in the perspective, you're one of the few teams that have actually flown from Kingaroy into the search area, conducted a search and come back. So
that's outstanding.
I know that there's frustrations with the video, but you've done really well, so take that away as a positive. Air Boss, this is Control. Arc Coordinator, over. Be advised that Compass UAS have started their 15 minutes preparation time and will be looking for airborne soon after that. Over. Gentlemen, your 60 minutes starts now.
We saw the plane going away just like it would normally, and we switched off our remote control on our pilot's control, and for some reason, well, we weren't very sure what the reason is, the autopilot thought, okay, I need to go back to manual mode. As soon as it hit manual mode, our safety system set in and said, okay, it's dangerous for you to be in a manual mode and the remote control to be turned off, and it killed it.
That's another team out.
It's well outside of the area by my calculations.
Yeah, it is outside the area. I saw it in the jet.
Unfortunately, the Dutch team, Open UAS, has disappeared off the radar. So far, no teams have been successful in the mission.
The team from Canada, Forward Robotics, did a great search phase. They were searching, they covered 65% of the search area. They came back to download their images, only to find they didn't have any images. There was some problem with recording of the images. Compass UAV were doing very well. They did a great takeoff, went into across the boundary of the aerodrome, and then we don't know what happened yet, but suddenly they spiraled down into the ground. Our Dutch team, Open UAS, their wing fell off in the Kingaroy Triangle as they were flying along. It's a mysterious thing.
There is only one team left who has a chance of saving Joe.
Holding back elevator, launching in 3, 2, 1.
So in Australia, to become a UAV operator, you have to have something called an operator's certificate, and this is something that's issued by the Civil Aviation Safety Authority, CASA, and in order to get that certificate you have to go through some training, you have to develop operations manuals, and you have to show competence that you can safely operate a UAV.
So a typical unmanned aerial vehicle, obviously it's no different from a normal aircraft on a day-to-day basis. When we look at this, it's just a miniaturised version of a Cessna or even a 747. And what we really need to understand is that this is sharing the airspace with other aircraft, right? And really a big part about this is not just the fact that we're flying a particular mission below 400 feet for farmers or for whatever the mission may be, but we are actually sharing airspace with other aircraft.
We've just completed our first, what we call an RPAS basic training course, which effectively puts guys through a 2-week crash course in how to operate and control in a safe way a UAV. The whole purpose of that is to enable them to get their licence to be able to start flying and build up their experience.
It will take off and land.
What we then start to do towards the end of the first week is start to get them to work on the simulators. Now the simulator is effectively very similar or almost precise as to what they will experience out in the field.
So what I want you to do now is I want you to move the waypoints on the screen, and then I want you to write them so that the packets of data goes back up to the remotely piloted aircraft. So just move your points around on the screen. That's it.
We can basically, train the guys on the simulator first and get them to then repeat it on the aircraft out on the field, and the differences are very minimal.
Remain stabilised. Now what we'll be doing is you will indicate ready for launch, 3, 2, 1 on 1. You'll throttle up to full and call launch, and you will throw the aircraft out in front as level as possible.
It is our intention as an organisation to make sure that the pilots going out there have reached a certain benchmark, which not only is acceptable to CASA, but acceptable to industry, and that will make sure that the industry can actually grow. If we have too many incidents in the early days, it will make it very difficult for the industry to succeed, particularly in the civilian sector.
So currently when you get an operator's certificate, you have to operate your UAV within line of sight. So that's you're on the ground operating the UAV, you have to be able to see it. In the UAV challenge, of course, we fly the aircraft, or the teams fly the aircraft up to about 10 kilometres away from the ground station. So we get around the line of sight issue by having our marshals dotted around the course, and they're in constant radio contact with the safety marshals, the judges and the teams.
Flight time has commenced.
F50Y stabilisation check.
Yes, we have.
Camera stabilisation.
Yes, we have.
Great. We need barometer calibration, please. Cover the airspeed sensor.
Yep, we're about to do another left turn down the search area again.
173, Paul. 173. Estimated time to mission completion, 32 minutes. GPS speed, 33 metres a second, on track. Wind estimate, 5 metres a second, 12 degrees. Winds very gusty. Antenna 175, Paul. 175.
Okay, we're about to do another left turn.
Turning left. Looking good. Antenna 168. We're going to push the throttle up. We are losing speed.
Altitude's still okay. It's maintaining altitude. It must just be the wind.
With the wind, that's a lot of wind. We are crabbing at an angle of 30 degrees in the wind. And perfect tracking along at an angle of nearly 30-35 degrees crab. We have completed the first half of the search.
We're now going to go back and...
We're now doing the interleave search, where we're doing a mowing the lawn interleaved pattern. Right. So we're covering every square metre of ground twice. Antenna 159.
159.
The rain is slower than we expect. We think there might be drag from the bottle.
Understood.
Yeah, we think it's still attached, but we've got a sensor for whether it's attached, and the sensor's showing detached.
5 minutes, 25 minutes remaining.
Thank you. We've got Joe.
Think you found him?
Okay, it's reasonably centred, 1/3 across the image. We have a yellow top, we have blue jeans.
Oh yeah,
that was
great.
one of the highlights of the past 18 months is knowing that just it being displayed that our system worked. It worked as we designed it first time, which is an awesome feeling.
We're confirming it's either Joe or someone that looks very much like him. We just got more photos of Joe.
Waypoint 109.
We got another 20 photos of Joe.
And so then in the later part of the flight, we got the really clear images of an absolutely obvious Joe, you know, yellow top, blue jeans, you know, it's just absolutely clear with the lamp even showing. And then it was just, you know, totally obvious. And the score was through the roof. So the computer said, yeah, this is it.
They actually had an auto Joe detector. So they had a computer on board looking at all the images, and they knew what Joe should look like, and they actually wrote some software to automatically find Joe, and that worked beautifully. And that's the first time we've seen that actually work this year.
The location we have is minus 26.636070.
You are very close, I would say that.
Canberra UAV have found Joe, but they haven't won yet. They still need to drop the bottle of life-saving water to our lost bushwalker. But they might not have a bottle to drop.
Now we may be doing a landing to replace the bottle. We have a second bottle ready. Waypoint 29, transitioning now. Now we may be doing a landing to replace the bottle. We have a second bottle ready. Okay, so we are going to go to the exit lane. Waypoint 29, transitioning now. The wind, it's too slow.
Take over, manual.
Take over, manual. Manual landing. Ignition off. Plane power can be disabled when you're ready. Panda board is off.
That was awesome.
The Canberra UAS plane has made it back, but it has suffered some damage during the mission. The judges aren't willing to risk it, so unfortunately the team can't complete the final stage of the competition, dropping the bottle.
I was disappointed that nobody won, because we've been saying every year, I'm sure someone will win this year. But Joe is still out there. So of course we had a team do extremely well with their automatic Joe finder, but they had some issues with damage to the aircraft, which meant that the water bottle was let go before they actually found Joe. So hopefully in the future this will be completed.
Wow. You've hit a bird and that's probably done the...
Oh God, that did the bottle. We must have hit a... Oh, the poor bird.
Oh wow, here's a bird, maybe.
Casualty.
About 30 previous drops we've tried, dropping that sort of bottle, no problems. And so, you know, 31st in the competition. Yep. That's why they say the Kingaroy Triangle, you know, it's cursed.
Yes. I mean, there's these things happen. You come here with everything working and you just get these random events occurring which can completely throw you off. I mean, you've seen that happen to other teams.
What happened during the flight? The bottle was ripped off, most likely due to high winds. The parachute was ripped off, got wrapped around the propeller, and then came off as well. It would have made the propeller a lot harder to turn. It's a miracle the propeller didn't stop or seize up and crash. And that's why we were going slower during the mission than we thought, because that was wrapped around it.
It's these very, very small things.
Yeah, that's right. So it means you've got to be really prepared. I mean, reliability,
it means that 30 tests wasn't enough. We needed to test more, and so next time we will.
You'll be back next time? We'll definitely be back.
I think
definitely.
So. It's nice up here.
And when the original organisers founded this challenge, they actually had some ideas about what they could go on to become. And so in a way there's a part of us that would like to say, well, let's take the next step and really add another dimension to this challenge, but we won't do that until this current format of the challenge has been completed, because obviously it still is a challenge for the industry to achieve, to take off from an aerodrome, search an area, find Joe, give Joe's locations accurately, to drop a water bowl and then return safely to the airfield. And until we can do that, there's no point in pushing the boundaries even further.
For us, the point of this competition is to develop the amateur UAV technology to the point where it can be deployed by organisations like the Bushfire Services, the SES, Police Rescue and others, and to make UAV technology affordable and practical in real rescue situations.
With the unmanned aircraft industry going ahead in leaps and bounds, nowhere is the saying, the sky's the limit, more accurate.
I think this is an exciting time for the industry. As I mentioned before, it's primarily been in the military domain, and it's now really starting to break out in that commercial domain. So if you think of where it might end up, I think right now is just the start.
What the big industry benefit of unmanned aircraft is going to be, we haven't even thought of yet.
All these different ideas will pipe out of the woodwork, and we will modify the technology to do the work.
We want to employ UAVs or UASs in a manner that just puts people in a better, safer place, allows technology to be the workhorse and not the person.
A lot of the challenges in our research is how do we take what we expect from our human pilots and put that into what we call autonomy.
So I can see a time when, it might start off with freighter aircraft crossing the Atlantic with no people on board. And then as people get confidence, you might find that you're sitting in the back of your Qantas 747 and your pilot's actually on the ground in Sydney rather than in the front of the aircraft. So I can certainly see that happening once people start to understand and trust the technology.